Hello everyone, and today we're going to talk about how to construct a box and whisker plot for statistical analysis. So let's get started. Okay, so first thing you're going to need to have some definitions here. So our median is the middle of our data set. Quartiles, we have two of them. They have the upper and the lower. Okay, that represents 25% of our data, just like a quarter is 25% of a dollar. Okay, technically you could call it the median of the medians, because again, what we're going to do is find the median, and then we're going to repeat the process again to get the quartiles. Then we have interquartile range, which is the largest quartile minus the smallest. We have outlier range, so it's always 1.5 times the interquartile range. The lower limit, which is the lower quartile minus the outlier range. And this shows us where the outliers begin. And then we have the upper limit, which is where the upper quartile, we add the outlier range, and this shows us where the upper outliers will start. So again, you might want to pause the video here, jot those things down, because we're going to be referencing these a lot. And again, going over them kind of quickly, you won't really remember what these things really mean and when we talk about them later on. So again, I would suggest you pause the video, jot these terms down, what they mean, before moving forward. All right, but in the meantime, if you're ready, we're going to kick this thing off. So let's move on. All right, the process. Now again, I'm going to give this to you, and then we'll have this in our steps. So again, you might want to pause the video and jot these down. Again, in the slides later on, I'll probably have these steps on the side so we can reference them. But the first thing we're going to do, anytime we deal with data, we need to organize our data from least to greatest, so we're going to put them in order. Then the second thing we're going to do is we're going to find the median. So we count towards the middle from both ends of our data set. If we land on the same number, this is our median, which is easy. If we land on two different numbers, we have to take the average. That means we take the two numbers, we add them together, and divide by 2. Then we're going to find the upper and lower quartiles. So again, we count towards the middle of the ends of your lower and upper data sets. The median is what splits them in half. And again, you'll see that when we start doing these. If you land on the same number, again, it should be the quartile, not the median. And if you land on two different numbers, we take the average. Okay, then we calculate interquartile range. So there's the formula. Then we calculate the outlier range, which is 1.5 times interquartile. Then we find the lower and upper limits to determine where our outliers are going to start. Then we identify our outliers. These are any points that are above and below the upper limits. And then we graph up. Okay, so again, a lot here. So again, I suggest you jot this down. Again, it should be in our slides later on. But again, it's a good idea to have these in your notes and jot them down. So if you're ready, let's move on. If you're not, pause the video, and then when you're done, hit play to move on. All right, so here's our first example. So we have our data set. Okay, we're given this right here, and we are asked to create a box and whisker. So one of the first things we're going to have to do is put the data in order from least to greatest, from smallest to largest. So looking at my data set, the smallest number I see is 15. Then I see a 20. Then I see 25. Then I see 30. Then I see 40. Then I see 55. Then I see 60. And then I see 70. All right, so step 1, arrange your data from smallest to largest. Okay. Now, next thing we're going to do is we're going to count towards the middle. We got to find the median. Okay. So what we're going to do is we're going to start our count. So 1, 1. Again, usually I would show you with fingers and pointing, but again, I'm not going to be able to do that, so I'm going to kind of do it this way. So moving towards, this would be 2 and this would be 2, 3, 3, 4, and 4. Now notice, I can't go any further, but I'm on right now 2 separate numbers here, which means in order to get my median, I have to get the average. So we're going to take 30 and 40 and divide by 2. And when we do that, we get 35. So our median is going to be 35. So what I like to do is I like to throw like a little line in here, put a little box, and that's 35. Okay, so there's our median. So step 2 is now done. All right, so let's get rid of this stuff now. Now, our next step is we now have to find the lower and upper quartiles. So we're gonna, this is, the median acts as my split. So this stuff down here is my lower data set. This stuff out here is my upper data set. So to find the lower quartile, we're gonna repeat the counting process with our lower data set. So counting towards the middle, I got 1, 1, 2, 2. And again, unfortunately, I wound up on the same number. I didn't land on the same number. So we're going to have to do our average. So 20 plus 25 divided by 2, which will be 45 divided by 2, which will be 22 and a half. And yes, you can get decimals as your quartile or even your median. So I like to put a little sign up here. This is 22.5. Okay. Now we're going to do the same thing on the high side. So 1, 1, 2, 2, and again I'm winding up in the middle here. So when I average those together, okay, 55 plus 60 divided by 2 is going to be, that's going to be 57.5. So this is my upper quartile. This is my lower quartile. And as we said earlier, the 35 is our median. All right. Now, here's where the math comes in. For our next part, step 3, is we're going to calculate interquartile range, IQR. So you're going to take the upper quartile and minus the lower quartile from it. Oops. L. There we go. So in this case, we're going to take 57.5 from my upper quartile minus 22.5, and I get 35. So interquartile range is going to be 35. Great, so that step's now done. Now our next step is we are now going to find the outlier range. So remember, to do outlier range, it's 1.5 and it's always 1.5 times your interquartile range. So on our example, it's going to be 1.5 times 35. So 1.5 times 35 gives me 52.5. So this, what interquartile range or outlier range tells me, oops, OR. What outlier range tells me is how far away from the quartiles will the outliers begin. Okay, so let me kind of shrink this down a little bit here, scooch this so I have more room to work. Okay, our next thing we have to find is the low and the high limits. This is going to tell us distinctively where our outliers start. So at what number does a number become an outlier? So to do the low limit, we take the lower quartile and minus outlier range. So in this case, we're going to take 22.5 minus 52.5, And when I do that, we get negative 30. So we ask ourselves, do I have any data points below negative 30? Now, the lowest data point I had was 15. So do I have any data points lower than negative 30 to be considered an outlier? The answer is no. So 15 is an okay number. We don't have any lower outliers, and that's okay. All right, for the high side, we're going to take the upper quartile and add outlier range. So we're going to take 57.5 and add 52.5 to it. And when I do that, I get 110. So looking at my data set, do I have any data points above 110 that would be considered an outlier? Well, no. The highest data point I have is 70. So all my data is good. None of these data points are considered an outlier. So we are ready to start constructing. We're ready to start constructing our box and whisker plot. All right, so here we go. We're going to make our box and whisker. So we start with a number line. Let's start with 10. Let's go 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, whoops, 65, 70, 75. I like to do a little extra on either side. All right, so to construct the box and whisker now, we're going to start with our data here, the lower quartile, median, upper quartile. All right, so when I draw it in, lower quartile was 22.5. So I'm going to find approximately where it is. I make my line, and I like to put the data above so people can easily read my graph, so they don't have to guess at what it is. So 22.5 there. Our median value was at 35. So at 35, I'm going to make my line here, right there. 35. Upper quartile is 57.5. So I'm going to go to 57.5 on the number line, right about here-ish. 57.5. Oh, hey, come back here. There you go. All right. So now that we got those in, this makes up the box. So we're going to do this. Like so. So there's the box. Now for the whiskers, for the lower whisker, it's the lowest data point that is not an outlier. So lowest data point I have that was not an outlier is 15. So we're going to go to 15. Make my line. Here's 15. And to do whisker, just connect it like that. Now for the upper whisker, largest data point not an outlier was 70. So let's go to 70. Connect the dot. And there's the construction of the box and whisker. Now, neat things about box and whiskers, between these values, so between the lowest value you have and the lower quartile represents 25% of our data because we split the thing up into 4 pieces, quartiles. Between the lower quartile and the median is 25% of your data. Between the median and the upper quartile is 25% of your data. And upper quartile to the maximum, again, is 25% of your data. Okay, so again, 100% of your data, and again, this shows you how much of the data was where. Okay. All right, so let's take a look at another example. All right, so I have this data set. So the first thing we're going to want to do here, let me shrink this down because I know I'm going to need a lot of room for this one. All right, so let's start by organizing our data here. So lowest data point I have, actually, yep. Lowest data point I see here is 19. Let's see, in the 20s, I got 20, 21. Looks like I got two 24s, and that's okay. Then we have two 26s. Okay, then we have 31. We have 32. 32 again. There's a second 32 there. We have 41. And we have 52. Come on. Hey, stop disappearing. 52. All right, so step one, putting your data set in numerical order from least to greatest. All right, next thing we do, let's count towards the middle here. So we have 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. All right, again, I did not land on the same number. I didn't land on the exact same number. However, in an ironic coincidence, if I average 26 plus 26 divided by 2, I still get 26. But again, because I didn't land on the same number per se, these 26s here and here are going to go back into the data mix for my upper and lower limit. If I did land on the same 26, then that's my median and we have to take it out. Okay, so there's my median. All right, so now let's talk about the upper and the lower quartile. So again, we're going to kind of count towards the middle here of our data set. So the lower set, so 1 and 1, 2, 2, 3, 3. So again, I didn't land on the same number, so I got to take the average. So 21 plus 24 is going to be 45. Divide that by 2, I get 22 and a half. So there's my lower quartile. Hey, stop it. All right, now for the upper quartile. 1, 1, 2, 2, 3, 3. So again, I didn't land on the same number, so we got to split it a little bit here. But again, 32 and 32, the average is going to be 32. All right, so there's my upper quartile. All right, now for the math part. Interquartile range, IQR. Upper quartile minus the lower quartile. So we're going to have 32 minus 22.5. And when I do that, we get 9.5. So my interquartile range, 9.5. Next is our outlier range, which is 1.5 times the interquartile range. So we do 1.5 times 9.5. I get 14.25. All right, so interquartile range is 14.25. So now we're going to do our low and our high limits. So the low limit says we're going to take the lower quartile and minus outlier range. So the lower quartile, 22.5, minus 14.25. So 22.5 minus 14.25. Oh, should be 8.25. So we look at our data set. Anything below 8.25 is considered an outlier. So looking at my data set, do I have any data below 8.25? And the answer is no, because the lowest data point I have is 19. So that's no good. So we're good. No lower outliers. All right, let's go to the high side. Upper quartile plus outlier range. So we're going to do 32 plus 14.25, and I get 46.25. So any data point above that is considered an outlier. And as we look this time, 52 is above 46.25. So this data point is considered an outlier. So what we're going to do is I'm going to put a little asterisk underneath it, or you can do it above it, assuming my pen will work here. Hey, draw the asterisk, stupid thing. There we go. Indicating to me that that 52 is an outlier. That doesn't make sense with the rest of our data. Okay, so, and I'll show you how to graph that in a minute. Okay, so now that we're set, let me scrunch this down. Hopefully, and of course it's not going to go all together here. So I'm going to scrunch this, kind of move this over here. I'm going to shrink this down. Hey, of course, you know what, there. Didn't go all together. Fine. Be that way. All right, so here we go. Let's draw in our number line. So here comes our, oh, that's terrible. Let me try that again. Let's try that again. That was awful. That's a little better. That's nice. All right, so I'm going to start. It's going 18 and 52. Let's go by twos. 18, 20, 22, 24, 4, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52. I like to do one more, so let's do 54. And again, I like to do a large spread like this so I can easily put in the data points a little more easily. All right, so let's start graphing up. So we start with the lower quartile, 22.5. So right about here-ish. 2.5. Okay. Median is at 26. 26. Upper quartile at 32. 32. And again, these pieces make up the box of the box and whisker plot. So it looks like that. All right, now, lowest data point I have that is not an outlier is 19. So let's go to 19, right about here-ish. It's 19. Largest data point that is not an outlier. So when I look at this, remember, we identified 52 as an outlier, so I can't count this one. So the next data point down that I have is 41. So the largest data point I have not an outlier is at 41. So there's our box and whisker. Now, to take care of this outlier, what we'll do at 52, let's throw just a little star in there. And I'd like to label it so people can easily read and understand what I'm looking at. So it also shows us that, again, we had 52, it was in our data set, again, and it doesn't make sense with the rest of our data, so it is considered an outlier. All right, so let's take a look at the next one. All right, so I'm gonna shrink this down a little bit. All right, so I'm gonna let you guys try this on your own. I'm gonna give you about a minute and a half or so to work on this one. I'm gonna step away. Now you can keep the video running, okay? Again, I won't stop the video, just keep it running. In a minute and a half, I'll come back and we'll start processing this problem. So here we go. All right, guys, I'm back. All right, so again, if you haven't finished, you can pause the video, but I'm just going to get started here. All right, so first thing we do, let's organize the data from least to greatest. So the smallest data point I hear is 65. Next one I see is 70. Next one I see is 75. Next one I see is 79. And I have it twice. Then I have 81. And we have 86. And 91. Alright, so there's my data set from least to greatest. Alright, so our next step, let's go find the median. So we're going to count towards the middle here. So 1 and 1. 2 and 2. 3 and 3. 4 and 4. And again, I didn't on the same number, so we're going to have to average it. But nicely enough for us, 79 and 79 divided by 2 is 79. Okay. All right. Now that we have that, let's go get, oops. Hey, give me my eraser. Oh, you're not going to erase it now, huh? Okay. All right, so our next step, let's go count, get our quartiles. I can't erase that right now. I don't know why. So 1, 1, 2, 2. So the middle between 70 and 75 would be 72 and a half. 1, 1, 2, 2. Again, finding the middle here. So that's going to be 81 and 86. That's 167. Divide that by 2 is 83 and a half. All right, so there's our quartiles. All right, now for the math. Here we go. Interquartile range is upper quartile minus the lower quartile. So we have 83 and a half. Oh, come on. Oh, my pen shut off. Hold on. 83.5 minus 72.5. So we get 11 as our interquartile range. Okay. Our outlier range is next. Remember, it's always 1.5 times the interquartile. So in this case, 1.5 times 11 gives me 16.5. All right, now for our low and our high limits. All right, so here we go. Low limit, lower quartile minus the outlier range. And again, this is going to tell us where our lower outliers begin. So we have 72.5 minus 16.5. So when I do that, I get 56. Okay, so we have 56. So we look at our data set. Do I have any lower data points below 56? The answer is no, so we don't have any lower outlier. Let's go to the high side. We're going to do the upper quartile plus the outlier range. So we're going to take 83.5 and add 16.5. So we're going to have 100. So we look at our data set. Do I have any data points above 100? The answer is no. So we don't have any outliers. Okay. Let's see if this will all scooch together here. Nope, of course not. Okay, so let's move this stuff out of the way now so we can make our graph. Okay. All right, so let's make our graph now. All right, we're going 65 to 90, so let's do 60. I'm going to go by 5. 65, 70, 75, 80, 85, 90, 95. All right, so let's do this up. Lowest quartile, 72 and a half. Median, 79. So closer to 80. Upper quartile, 83.5. So there's my data set. There's my box. Whiskers, lowest data point on an outlier is 65. Largest data point I have, not an outlier, is 91. And there is the box in Whisker. Alright, so that's the end of this tutorial video. Hopefully you got a lot out of this, and I will see you next time.